When it comes to establishing load, what we're trying to do really is to ensure that we have indeed applied enough stress overload to stimulate adaptation with the clients. And so the question is, well, how much intensity or how much overload do we actually need? Now, we have a wide range here. We have what is the minimum effective dose, and then we have the maximum tolerated dose. So this would be the maximum amount of work that someone could effectively recover from. This is the minimum amount of work required to stimulate adaptation. Right below that, the minimum retentive dose. This would be the minimum required to maintain where you already are. So if you've been training for a little bit and you've experienced some adaptations, there's going to be a stimulus required to maintain those adaptations. Obviously, if we're trying to make new adaptations, we're going to have to apply a little bit more stress. And we know then, from a best practice perspective, over time, we're really looking at applying that minimum effective dose repeatedly to result in meaningful adaptations. The risk, of course, that we run when we get up into higher levels of overload or stress is that we end up compromising recovery. We create too much overload, compromise recovery, and then all of a sudden it's time for the next session, and we haven't fully recovered or yielded any type of positive adaptation. Any discussion around training intensity or the appropriate dose of overload has to have some type of metric to start with, and the metric that we're going to have is absolute maximum overload stress, etc., which would be taking our resistance training sets to absolute failure. That means the person has reached the point where they could not perform one more repetition with proper technique. Essentially, they have maxed out their neuromuscular resources. They cannot produce enough force to do one more repetition. This, of course, then represents the maximum amount of overload or stress that we could have applied. And the question is, do we need that? Do we need the maximum amount of stress? Obviously, from the previous slide, you know, no, that's not the answer. It's the minimum amount of stress required to initiate adaptation. And so I posted an article that discusses the application of training to failure, the pros and cons of potentially training to failure on a repeated basis. One of the things you will learn is that going to failure is not recommended on a regular basis. It's way more overload than is required. It can compromise recovery and things of that nature. So one of the things we realize we need is a way to regulate intensity, a way to make sure that the clients are going hard enough to stimulate adaptation, but not too hard as to maybe compromise long-term training adaptations. So we're going to go over 6 ways that we can regulate intensity. The first one is we would have our target rep or zone, and overload is just implied. So for example, if I was programming and I wanted 3 sets of 10 to be performed, it's assumed the client will reach sufficient overload at 10 reps. And this is really very common. This is what most of us will use when we're working with clients. We'll say, yeah, we want 10 repetitions. That 10th rep should be pretty difficult. It's going to be pretty uncomfortable, but you could probably get 2 or 3 more if you really, really, really tried. But there are other ways that we can regulate this by using metrics, so we're going to go through those. The rating of perceived exertion. This is programming based on how difficult the set should feel, based on how many reps the client could perform. So for example, I might have my client do 3 sets of 10 repetitions at an 8 RPE. And we'll go over what RPE represents and how you can give your client some context for that. Another way we could do it is via repetitions in reserve. Very similar to RPE, programming based on how difficult the set should feel, but this changes the perspective. In this example, reserve is like extra. So how many extra reps could you have performed? These are all methods of keeping people in proximity to failure. So how far from failure are we? Then we have our percent 1RM. Obviously, we can program based on the percentage of 1RM. For example, I might have a client do 3 sets of 10 repetitions at 70% of the 1RM. Then we have relative intensity. Now, this is also percentage-based programming, but this is based on, again, how difficult should the set feel relative to that maximum feeling 100% intensity. Finally, we have a percent of what's known as our training max. Rather than basing loads off of the true 1RM, we base loads off of what's known as a training max, which is often going to be around 90 or 95% of someone's true 1 RM. So now we're going to go and look at each of these individually. From an effort level of training standpoint, so remember what we're talking about here is how do we give our clients some context as to how difficult the set should feel. Now we have the RPE scale, rating of perceived exertion, and a lot of people are familiar with the aerobic training version or the application of an RPE scale for aerobic training. Here's our scale, 1 to 10, how difficult does it feel, etc. Well, we have a very similar scale for lifting. 10 represents absolute maximum, right? 10 out of 10, of course, you could not go any harder. So that's going to be failure. And then if we're at a number 9, generally that's about 1 repetition short of failure. And if we happen to be at an 8, person could have done 2 more reps, 7, 3 more reps, etc. So here's an example of using RPE in programming. 3 sets of 10 at an RPE of 8. Now, we still have to figure out the load, the trial and error portion, right? What weight is going to result in the client feeling as though they're at an 8 out of 10, which of course we know represents they could have done 2 more repetitions. We've applied RPE, and now it's the same concept of RPE, like how close are you to failure, but we're giving a different perspective. We're using what's called repetitions in reserve. And so for this one, what we're seeing, of course, is if a client says they have 0 repetitions in reserve, or we program 0 repetitions in reserve, you've reached failure. You could not have done another one. You don't have any extra reps there available, right? And then, of course, we have 1 rep in reserve. We have 2 reps, 3 reps, so on and so forth. These have also been scaled. So these, of course, are very difficult, lots and lots of stress. And then, of course, we see things that are going to be a little bit easier to recover from. So here's our example. Still 3 sets of 10 on the front squat. This time I want 3 RIR. Now we know that's 3 less than failure, which if we wanted to, from RPE, previous slide, this is really going to be the exact same as our RPE of 7. It doesn't change the fact that we still need trial and error to establish the load that's going to yield this particular feeling. It's not uncommon to program based on the percentage of 1 RM, which of course is the maximum weight the client can lift for 1 repetition in a particular lift. And so you see the example of the prescription at the bottom here, 3 sets of 10 repetitions, this time using 75% of the 1 RM. So we don't have an RPE guideline here. We don't have a reps in reserve guideline here. We have an actual weight that they should put on the bar. And some people like this because it takes the subjective nature of feeling out of it, and there's just an actual number that goes on the bar. Now, how do we come up with these relationships? Well, that's what the chart on the right is for. The chart on the right shows the percentage of the 1 RM that's being used and the number of repetitions that someone should get, but it will result in failure. So for example, you put 100% of the 1 RM on the bar, the person gets 1 repetition, not 2. If you put 95% of someone's 1 rep on the bar, so we're talking bench press, squat, or deadlift, or something like that, they will generally get 2 repetitions. No matter how hard they try, they will generally not get a third. Getting 2 reps will result in absolute failure. Similarly, 5 repetitions, 87% on the bar. They will generally not get 6, right? Once they get to the 4th, they'll generally be able to get that 5th one as well. So this provides at least some type of context to get us in the ballpark. So what you can see here, 75%. How we use the chart is we know we wanted to prescribe 10 reps. So found my 10 repetitions. Went across, realized that is 75%. Now we have to know, again, this will result in them going to absolute failure. So if you wanted to keep them a little bit away from failure, obviously prescribe a little bit less than 75. You could drop down to 70. You could go 72. You could go 67. Just depends how far away from failure you actually want the client to be. The relative intensity chart is kind of an extension of what we talked about on the previous slide. This allows us to still use an actual percentage of the client's 1 RM, so it takes the subjectivity out and provides an objective representation of how difficult a set should feel. What you're seeing on the chart then is the relative intensity are the numbers here in black. So this is relative to your maximum. We want you to work at, let's say, 76% of your maximum abilities, or I want you to work at 91% of your maximum abilities. Then we see the number of reps we are prescribing on the top, and so all we need to do is line up the number of reps we are looking to do with how hard we want the client to work. The number in the middle of the chart is the actual percentage of the 1RM that goes on the bar to yield the feeling that we want for the number of reps we have prescribed. So we're going to look at an example of using this on the next slide, but before we go on, I want to note that anywhere from about 88 to 82% relative intensity seems to be considered to be a pretty optimal zone in terms of stimulating adaptation without compromising recovery. So here's an example of using the relative intensity chart here. So I want the client to work at 88% of their maximum abilities. All right, so what I'll do is I want 88% for sets of 5 repetitions for my client. So all I need to do is line up the number of repetitions that I want. So 5 repetitions. And we want them to work at 88% of their maximum abilities, or 88% relative intensity. So let's line up these numbers. I just go across 88 down from 5 repetitions, and the intersection is 76. That is 76% of their 1RM should yield a feeling of working at about 88% of your max abilities for 5 repetitions. Now, if we know the client's 1RM, we could actually do the math here, work that all out, so we know the number on the bar. So this takes RPE out of it, this takes feeling out of it. This is an objective representation of how difficult we have the client working for certain lifts. The final method that we'll present for regulating intensity or proximity to failure is that of a training max. Now, a training max is really a max that you could hit on most days, as opposed to an absolute max or your all-time 1RM, sometimes referred to as a competition max if people are competing in powerlifting. But either way, your 1RM for a lift is the maximum of weight that you've ever done in a lift. And maybe it was a great day. Maybe you had really good sleep, good nutrition, good warm up, and everything just worked that day. But the question is, could you hit that pretty much every day? So if we take a training max, it's usually about 90% of the true 1RM. So we make all of our calculations then from a percentage-based standpoint off of the training max and not the true max. Example, client has a 1RM of 350. Training max is going to be 90% of that. So I take 90% of 350, 315. And this becomes the weight that I do all of my prescribing off of, 315. So still working with front squat, 3 sets of 10, percentage 75. Now, if you go back to the chart a couple slides ago, we know that 75% for 10 repetitions usually results in failure for most people. But we're now at a method to keep people a little bit shy of failure. But this is based on true 1RM. Now we're not based on your true 1RM. We're based on 90% of the true 1RM. And so we can have a lot of confidence that they will complete 3 sets of this. It will not take them to absolute failure, but it will still be pretty challenging in order to stimulate adaptations. This is the overload, of course, stimulating adaptations, because we are in essence working at 90% of their capabilities. If we compare the methods that were just presented, there is a common theme, and that is somehow, some way, we are giving a metric relative to absolute failure. All right, so we have RIR if we want to, we have RPE down here, we have the relative intensity chart, we have the actual percentage chart, etc. For most people that we work with, this will be enough. Just tell them it should be pretty difficult, should maybe be able to do maybe 2 more repetitions, and that will be enough. Yes, you could extend that because we know 2 more reps is a certain RIR, it's a certain RPE. For different clients, you want to get a little bit more objective, different training ages, etc., different goals, which we'll talk about later in the semester. For maximum strength, for example, where we might want to use some actual percentages for certain lifts, then we can get into relative intensity and stuff like that, or training maxes. The 6 methods that we just discussed are listed at the top, but they are not without their limitations. From an RIR or RPE perspective, does the client actually have a metric for what failure feels like? It's very difficult to tell the client to go to an 8 out of 10 on an RPE scale or 2 from an RIR scale, because these both represent the same thing. You're 2 reps shy of failure if they don't know what failure actually feels like. Another thing that might not resonate with certain clients based on personality, etc., is the subjective nature of these 2 measurements. Maybe somebody is thinking, yeah, I'm at a 10 or I'm at an 8, but they're like maybe feeling, maybe I'm a little bit lazy. Like I could maybe get 3, maybe I get 2, I'm not too sure. Or the opposite side where people say, yeah, no, I was just at an 8 out of 10, but they clearly were at failure. So in order to help navigate this potential issue, I've posted an article, a research review that looks at this. Can people accurately gauge their RPE? For the final 3 methods, or the 3 on the right, these all require us to know the client's actual 1RM for the exercise in question. And so now we have to think, is the exercise we're looking at programming conducive to 1RM testing? Single joint exercises are not conducive to 1RM testing. You're not going to do a 1RM bicep curl, puts too much strain and stress on the tendons. Then we also have to think about the training age of the client, their movement abilities, their technical abilities. Do we feel comfortable taking a client through a 1RM test just to get prescription based on, again, their training age, technique, etc.?